Now that we're interested in learning more about Puppet, let's take a look at why we might want to use Puppet and how it fits into the overall system management and configuration management space. First, we have to note that Puppet is a choice among many different configuration management tools. Some of these are open source or commercial offerings, such as Ansible, the Salt Stack, Chef, and many other tools that are available for managing and maintaining system and software configurations. One of the advantages I find of using the Puppet language in the Ecosphere is that the Puppet language is focused on being declarative. What I mean about being a declarative language in Ecosphere is that the Puppet language encourages you to define the end state of a system, the resources that are defined on a system, and the dependencies that those resources have on one another. When we write code using the Puppet language, we have to think about and define how that system should behave, and not necessarily a top-down instruction set that defines how we deploy and configure our software. The Puppet Ecosphere also has a very rich tool set of both open source and commercial offerings that can help you maintain and define an entire infrastructure with Puppet. Puppet also has the backing of a commercial company named Puppet Labs based in Portland, Oregon. Puppet Labs is a company that has been around for a number of years, and you can find more about Puppet Labs and its offering by visiting its website at puppetlabs.com. Puppet Labs offers tooling such as Puppet Enterprise, which can be a fast on-ramp to learning Puppet. They also offer training and quality assurance and support of Puppet Labs products. Let's take a quick look at the Puppet language. If we take a look at two snippets of Puppet code, we can easily read and understand what these two snippets mean. The first snippet is identifying a specific file type called a directory on a computer system, with an owner and a group. The Puppet runtime uses something called the resource abstraction layer to ensure that we can define a resource and not be concerned with the individual commands used to create that resource at runtime. For example, this definition of a web directory can apply on a Linux system, it can apply on a Mac OS X system, and it can even apply on a Windows system. In the modules we create, we can identify a type called a file and leave it to the type and provider system of the resource abstraction layer to do the dirty work of creating that file on our system. The same is true for identifying a local network host. This is one here where we may be identifying a virtual host in a web application, for example, to use a local IP. Again, we can identify this using this Puppet language in a very concise and easy to understand way, while a provider underneath will do the dirty work of creating that entry and setting those parameters independent of what operating system it is. So we can port our Puppet language from system to system in a way that allows us to define the things that we want to define and not the steps taken to define them. The Puppet Ecosphere is also a very large and rich set of tools and ways of accomplishing the things that you'd like to accomplish in your infrastructure. The Puppet Ecosphere is mainly based around the interactions of Puppet agents and Puppet masters. Agents are the key to doing things in a Puppet environment. A Puppet agent is responsible for maintaining, installing, and configuring software on individual servers and individual compute nodes. Puppet masters can maintain the catalogs and the definitions of our infrastructure in a centralized and scalable manner. We can create a Puppet master infrastructure that will define and serve those definitions to tens to hundreds to thousands of individual agents running on server nodes. The Puppet Ecosphere also contains centralized reporting tools that we can use to not only know about the status of the Puppet runs and the changes on our system, we can also use it to find out information about every single node in our infrastructure. And a large way to see, for example, what percentage of servers we have that may be running a specific software package, down to the individual level, where we can see what software is installed on individual nodes and how things have changed over time, and if the Puppet agents and masters have noticed any changes that have happened outside of this configuration management approach. The centralized reporting feature gives us an insight into our infrastructure that we might not otherwise see. Puppet also provides a tool for live systems management called mCollective. mCollective, or the Marionette Collective, is what allows us to control the actions and the interactions of tens to hundreds to thousands of Puppet agents across an entire infrastructure. So when we use M Collective, we can have a very live and real-time view into what services and software may be running on our system, and even a live way to push changes, such as package updates or even software deployments to each individual node in our system. Either all at once, one at a time, or in groups, M Collective is what allows us a real-time command and control over our entire infrastructure. I would be amiss without mentioning the very large and very vibrant Puppet community. Puppet was started as an open source project and continues to be open source and encourages others to develop source code that allows Puppet to be extended and used in many different ways. One of those ways is the publication of Puppet code on the Puppet Forge, which is a centrally located repository of Puppet code, which you can use to search and find modules that help you deploy nearly 3,000 different types of software and systems on your systems. The Puppet Forge encourages users and contributors to create modules that others can use. So even if you are just getting started using Puppet, you can find Forge modules that will help you do very powerful things very easily and very quickly. You can see all of the individual products that make up the Puppet ecosphere on GitHub at https://github.com/puppetlabs. That will give you an idea of the types of tools and the types of development that goes into the Puppet products and the types of things that you can use in your own systems. And finally, Puppet is backed by a commercial company called Puppet Labs, based in Portland, Oregon. You can learn more about Puppet Labs by visiting their website at puppetlabs.com. Puppet Labs provides several commercial offerings related to the Puppet ecosphere, namely a tool called Puppet Enterprise, which combines all of the various tooling that we can use in an open source fashion, packages them in a way that is easy to install, easy to manage, and has some features that allow you to do things that may be very difficult to do in terms of maintaining and creating an infrastructure using Puppet. Puppet Enterprise is a great on-ramp to be able to do very powerful things very quickly, using all of the tools in the Puppet ecosphere. Puppet Labs also provides some very excellent training, education, and support that you can buy or take advantage of by signing up for a multi-day in-person class and learning how to use Puppet to write Puppet code to maintaining larger infrastructures. Puppet Labs also sponsors an annual conference called PuppetConf, which is a 2 to 3 day event with many tracks and sessions on using Puppet and fitting Puppet into your own ecosphere. And Puppet Labs also sponsors several Puppet camps, which are much smaller one-day events that are held around the globe. If you'd like to learn more about these events, please visit the Puppet Labs website at puppetlabs.com, and you can find out more about the community, how you can learn more about Puppet, and even how you can get involved in developing the open source ecosphere of the Puppet environment.